The exhibit we have here today is called Stars Are Us, and really it's about the fact that everything on Earth, everything on every planet across space was made in stars. Every element, apart from hydrogen and helium, was created in a star. So essentially it's true to say that stars really are what we are made of.
And we put that in there to make the inside of this very cold. Obviously we take all the sweets out, we close it off.
We've got this emerging science called astrochemistry. Now, in the past, and certainly when I started studying astrophysics, we had no way of simulating the conditions you find in space in the lab, and in the last 10 years that's become possible. We can get really low temperatures, literally 10 degrees above absolute zero, minus 260, and we can get fantastically low pressures. And if you have those two things together, you can simulate the chemistry, the chemical reactions that you find in interstellar space.
Chemicals are really important because they actually provide a mechanism in which collapsing clouds of dust can radiate away their energy. We need to know how much of that energy is going to be radiated away and how the cloud is going to actually collapse and form a star that has planets that form a solar system around that star. So it's very important to know what kind of system is going to result, whether that system is going to be ready for life, if life can happen in that system.
The aim is to try and simulate the chemistry that goes on between the stars, and that's really important because there are a host of complex molecules in space. At least 200 have been identified, ranging from very simple sugars right up to almost amino acids. And it's very, it's fascinating that you find these things in space, inside these dark clouds.
We can find out what basic molecules there are in outer space, such as the molecules that are the building blocks of life. And by observing these, then maybe we can get an idea of how life actually came to happen on Earth.
This stand and this science brings together teams from across the UK and actually across the world, although I have to say this is science that's very strong in Britain. We've got astronomers, chemists, astrophysicists all working together, and the idea is that you need all those disciplines to make this science work. We've got people from Strathclyde here in Glasgow, from Edinburgh, from Nottingham and from London.
It's not usually filled with sweets. It's called the ultra-high vacuum chamber, and it's the container we use to simulate the conditions of space. We attach pumps to these apertures and we suck out the air inside. We use things like liquid helium, liquid nitrogen to cool the inside so that it's at a very low pressure and very low temperature, which is like the conditions in outer space.
A lot of us would believe that many of the materials for life were delivered from space by bodies like comets. Comets are big bodies of water, ice and other organic molecules. And it may well be that in the early solar system, when the Earth was forming, literally millions of comets were crashing onto the surface, perhaps filling up the oceans and also bringing some of the key ingredients for life. And that's why it's really important to understand what ingredients we can find out in space.